Here, I'm going to write this really quick. I'm going to say, look, let's write Z1 as, and this is where DeMoiver's theorem could be bypassed. And we're going to say Z2 is 3e to the pi over 2i. So when you multiply two complex numbers, you get complex numbers. If you're able to do this, you will be amazed by how quickly you could figure out these values. Instead of writing those in complex numbers and foiling, find Z1 times Z2. Z1 times Z2 would be 2e to the pi over 6i times 3e to the pi over 2i. 2 times 3 is a 6e. And what is pi over 6 plus pi over 2? Because remember, a to the n times a to the n is a to the n plus n. So instead of memorizing that as a formula, just get the common denominator, which is 6. That will be 4 pi over 6, which is 2 pi over 3. And if I want to go to complex form, I can easily. I'll just write that as a cosine of 2 pi over 3 plus. And instead of multiplying and foiling, I could pretty much get to my answer in no time by using Euler's form. And what if I wanted to find Z1 divided by Z2? Well, dividing by complex numbers is a mess because you can't have an I in the denominator. You have to rationalize. Check how quickly we can get this. That is 2/3 e. When you divide terms, don't you subtract powers? So if this was a minus, wouldn't that be 1 pi over 6 minus 3 pi over 6? That would be negative 2 pi over 6, which is negative pi over 3, but we know the angle must be positive. Instead of saying negative pi over 3, can't you say 5 pi over 3i? And how about if I wanted to take 1 over a plus bi? Again, that's a big mess. That is 1 over 2e to the pi over 6i. That is 1/2. What happened when you move an exponential? You can't have the angle being negative. That's a big no-no. So if you have negative pi over 6, isn't that the same as 11 pi over 6i? So as you see, in complex numbers, multiplying, dividing, adding, subtracting, that's really straightforward. And there is one that's going to really save you a lot of work when we get to it. So how about this second problem? Well, the same deal. If I could write this as, if I could say, look, Z1 is actually radical 2 e to the 3 pi over 4i, and I messed up, didn't I? Look at that. Would you look at that? That's what happens when you write your own problems, right? There, much better. Z sub 2 is 2e to the pi over 3i. Now if I say I want to find Z1 times Z2, well, that's simple. That's radical 2e to the 3 pi over 4i times 2e to the 3 pi over to the pi over 3i. And that's going to be 2 radical 2e. What is 3 pi over 4 plus pi over 3? All over 12. That is 9 pi plus 4 pi. What does that become? 13 pi over 12? 9 plus 4, 13. There you go. I. Done. That's simple. And what if I wanted to divide those two? What if I wanted to take Z1 divided by Z2? So what? Z1 will happen to be radical 2 e to the 3 pi over 4i. Z2 will be 2 e to the pi over 3i. This is going to be radical 2 over 2e, and you subtract those. if I put a minus there, isn't that 9 pi minus 4 pi, which is 5 pi over 12 I? And that's fine because that's still less than 2 pi. And if I wanted to divide one of those, if I wanted to take 1 over z sub 1, that is 1 over radical 2 e to the 3 pi over 4i. It's as simple as you saying this is e to the negative 3 pi over 4i. And if I have negative 3 pi over 4, if I add 2 pi to it to find the coterminal angle, that's 1 over, but you know what, let me shift this to the right a bit. That is 1 over radical 2 e, and if I add 2 pi to it, or what's that in the third quadrant, that is 5 pi over 4i. They said to leave it in polar form, so we're leaving it in polar form, and that's pretty much it. Extremely important for Math 55 when we get there, differential equations, for you to grasp what we're doing here, because we're going to tie everything together. Now, how about C? Well, out of those, I know that Z1 is 10 e to the 100 degrees I, and Z2 is e to the 300 degrees I. If I take Z1 times Z2, well, that is 10 e to the 100 degree I times e to the 300 degrees I. That's going to be 10e, and if you add those, when you multiply, that's 400 degrees I. That's too big. Subtract not 2 pi, 360. That will be 40 degrees I. There it is, done. With a calculator, I could figure that out if needed, except we're not allowed a calculator on this test. What if I wanted to take Z1 divided by Z2? Well, Z1 is 10 e to the 100 degrees I. Z2 is e to the 300 degree I. That is 10 e to the negative 200 degree I. I can't have the angle being negative, so add 360 to that. That's 160 degree I. So you must use polar on the homework. You must use polar on the exam. If you find the complex numbers, a plus bi, and use that, you'll get no credit. No credit whatsoever. That is 1 over 10 e to the 100 degree I. That is 1 over 10. By moving this up, that becomes a negative. An awesome property, if you ask me. And that's 1 over 10 e. If you add 360 to this, that's 260 degrees I. And there it is. Now we get to where we're aiming with all of this mess. I want to multiply those numbers. Of course, I could do this. I could always do that. But then I want to do this. So if you're thinking, I'm going to use the I, that's not allowed. Write those in polar form and find the following. What if you found the following without converting to polar form? You're missing the point. We're not after the answer. Hopefully by now you know that. So we're really after you grasping the concept, because this is where we're going with this. And believe me, I've seen students try to write this 400 times. They write 1 plus I. I don't know what they're thinking. And that's DeMoiver's theorem right there. That and this. So how does this work? Well, here's really where the section begins. Everything that I did up till now is just for you to be able from this to say, look, I could say Z1 is Z1 1 1. That is radical 2 e to the pi over 4i. Right? And I could say z sub 2 is radical to e pi over 4 in the fourth quadrant, 7 pi over 4i. That was the whole purpose of everything that I did up till now. I really wanted to start right here on example 5. Now, if I want to find z1 times z2, instead of multiplying those, I'll say that is radical 2 e to the pi over 4i. You do remember the answer was 2, right? I'm just going to show you it's the same thing. So radical 2 times radical 2 is 2 times what? E, if you take pi over 4 plus 7 pi over 4, isn't that 2 pi I? Done. Now, isn't that twice the cosine of 2 pi plus I the sine of 2 pi? What's the cosine of 2 pi? Isn't that a 1? Isn't that a 0? So isn't that just 2? So yes, if you multiply, you get the same result. We don't want you to multiply. We want you to use polar. That's the whole purpose. How about z1 divided by z2? Well, z1 is radical 2 e to the pi over 4i. z2 is radical 2 e to the 7 pi over 4i. That cancels out. I'm left with e pi over 4 minus 7 pi over 4 I. That is e to the negative 6 pi over 4i, right? Which is e to the negative 3 pi over 2i, which is another way of reaching. You could add 2 pi to that and make it pi over 2i. And we know where that is. That's really right there. And how about if I wanted to take 1 over z1? If I want to take 1 over z1, that is 1 over radical 2 e to the pi over 4i. That is 1 over radical 2 e to the negative pi over 4i. And since I can't have it negative, I need a coterminal angle. That's 7 pi over 4i. So keep in mind, everywhere I write e, the book will have a cosine of that angle plus I times the sine of that angle. Let's do another one. How about this problem? So this is the core of the section. I take z1 and I say if I move radical 3 to the right and 1 down, that's a 2. So r equal 2. I'm getting z1 to equal twice. And what's the reference angle? Tan of theta equals 1 over radical 3, 30 degrees, pi over 6. What's pi over 6 in the fourth quadrant? 11 pi over 6. Got it. Z2 is really simple. It's simple to see, but very hard to find using formulas. 2i. It's simply 2 e to the pi over 2i. Again, if you want to use degrees, I really don't mind. It's fine with me. So now if we say what is z1 times z2, you'll say, well, okay, that's 2 e to the 11 pi over 6i times 2 e to the pi over 2i. That is 4. And e, what is 11 pi over 6 plus pi over 2? All over 6. That's 11 pi plus 3 pi, which is 14 pi over 6. But 14 pi over 6 is bigger than 2 pi. So minus 6, that's 8 pi over 6, which is 4 pi over 3. Done deal. If I take z1 divided by z2, that would be 2e to the 11 pi over 6i divided by 2e to the pi over 2i. That is e. And if you were to subtract those, 11 minus 3 is 8 pi over 4, 8 pi over 6. And 8 pi over 6 turns out to be 4 pi over 3. How do you like that? They're not the same because r is not the same. And if I take 1 over z1, that is 1 over e to the 11 pi over 6i. That is 1 half e to the negative 11 pi over 6i. That would be 1 half. If you add 2 pi to that, that's pi over 6i. I could find what that is. I could plug the values in and get a plus bi if needed. I want to do one more before I conclude this video and start on the last section of this. So again, if I take this and I write z1, z1 is negative 3 radical 3. So r is right there. R squared is 9 plus 9 times 3. 27, that's 36, so r equals 6. And tan of theta equals the opposite over the adjacent, that's radical 3. And radical 3 would be 60 degrees, pi over 3. So what's that angle right there? That would be 4 pi over 3. What did I say? And negative 2. Negative 2 is easy. Right there. That is 2e to the pi I. So if I say find, and again it's crucial, if I find, say, z1 times z2, you would say that is 6e to the 4 pi over 3i times 2e to the pi I. That is 12e. What is 4 pi over 3 plus pi? All over 3. That is 4 pi plus 3 pi. That's 7 pi over 3. 7 pi over 3 is too big. Subtract 2 pi from that. That is pi over 3i. Done. What is z1 divided by z2? We would say that is 6e to the 4 pi over 3i divided by, what do we say, 2e to the pi I. That would be 3e. And if you subtract those, 4 pi minus 3 pi is 1 pi over 3. Those are not the same because one of them has a radius of 12, one of them has a radius of 3. 1 over z1 is going to be 1 over 6e to the 4 over 3i. That is 1 over 6 times e to the negative 4 pi over 3i. That's going to be 1 over 6. Add 2 pi to that. 2 pi, that's 6. That's 2 pi over 3. And that would be my final answer. I'm going to stop this lecture video here and conclude with the conclusion of why we're doing all of this.